Okay, now we're going to start talking about solving linear equations. You guys started this back in middle school, did it in Algebra 1, you did a lot in geometry, and now here we are in Algebra 2 just to revisit it. Okay, so now we're just going to start in on one-step equations, kind of where you started learning to solve. The thing to remember is the equal sign is what separates one side of the equation from the other. And I always find the side that has the variable, which in this case is x. And x is having 3 being added to it, so the inverse or opposite of adding is subtracting. And that's what eliminates the 3 over there on the left. And then I combine -2 and -3 is -5. Okay, the next one, separate both sides. Now this is 9 minus x. This is a positive 9 minus x. This is a positive 9 and a negative x. Those are all the ways to look at that equation. The last one, a positive 9 and a negative x, helps us as we move forward. So if that's a positive 9, I'm going to combine and give it a negative 9 so it eliminates. Another way to look at this, if this is more helpful, is I can rewrite this equation into a negative x and a positive 9 and solve it like that. I'm still going to subtract 9, okay? But this way I won't forget my negative if you're bad at remembering your negatives. So now I have negative x, and 5 and negative 9 is -4. Now I can divide or multiply by -1, and I get positive 4. Okay, the next one is separate the two sides. I have 3x equals -12. So that's 3x means 3 times x. So the inverse or opposite of multiplying is dividing. So I have x equals -12. I'm sorry, -4. And there you've seen my weakness. Okay, so this last one on this section is 1/2 x, which means 1/2 times x. I can also write this as x divided by 2. And so 1/2 x, I'm multiplying, I can divide by 1/2. Or I can multiply by the reciprocal, which is 2. But when I rewrite this as a division, I can know that the inverse or opposite of dividing is multiplying, so x equals 6. Okay, so now we're going to move on to two-step and combining terms and get a little bit harder, which was towards the end of Algebra 2. I still look for that equal sign, and I have an x on one side equal to something. So I have a 2 times x minus 3. We have to think of our order of operations, which you guys learned as PEMDAS. And we start at the bottom and move our way up. That's the order to solve an equation. So addition and subtraction is at the bottom, and I have a subtracting 3, so I'm going to add 3 first. So 2x equals -4. I move up, and next I am multiplying by 2, so I'm going to divide by 2, and I have a final solution of x equals -2. So start at the bottom of PEMDAS and move your way up. Okay, on this next example, I have the equal sign here. I see that over here on the left, I have 2 x's. I'm going to combine them together. So when I'm looking at this, the sign in front, the symbol in front is the sign of that term. So I have a -2x and a -1x. They combine to be -3x. That 7 is positive, and that equals to -2. Now I'm going to subtract 7, and -3x equals -9. I'm multiplying, so I'm going to divide by -3. Negative divided by negative is a positive, so that's +3. Okay, this next example, here's my two sides. I have 1/3 x minus 3. That's 1/3 times x minus 3. I can also rewrite that as x over 3 minus 3. But either way, I'm going to start off at the bottom of my order of operations and add 3 to both sides. So that's negative 2 equals 1/3 x. I can divide by 1/3, or I can multiply by the denominator, which is its reciprocal. So x equals negative 6. Okay, on this one, I have my equal sign here. I have x divided by 4 plus 6. Starting at the bottom, I'm going to subtract my 6. So x over 4 equals negative 4. I'm dividing by 4, so I'm going to multiply by 4. So x equals negative 16. Okay, now we're moving and we're finding our equal sign. And now we have the situation where we have the variable, in this case x, on both sides of the equal sign. It does not matter which way you go. I have a personal preference of keeping my x positive, because later on down the line, as we start solving certain kinds of problems, when you divide by a negative, we have to flip inequalities. So if you keep it positive, you never have to remember that. So the 2 is smaller, so if I subtract 2 from 6, I get positive 4, so that is where I'm going to start. So I have 4x minus 3 equals 13. Now I'm going to begin at the bottom of my order of operations with addition and subtraction, so I'm going to add 3. So 4x equals 16. I move up, and now I use division, and so x equals 4. Okay, this last one here on this page, there's my equal sign. I have a 3x on the left, a 9x on the right. If I subtract 9x, I get negative 6. But if I subtract 3x, I get positive 6. So that's where I'm going. Don't forget that negative in front of the 5. And now I'm going to subtract 7 from that x, and that's negative 12. And now I'm going to divide by 6, and x is negative 2. Okay, these are the last two of solving equations. Then we're going to move to the application problems. Find my equal sign, and I see over on the right I've got terms to combine. So I'm going to combine my 7x and my negative 2x first, and that's going to give me 5x minus 14 on this side, and that equals to 8x plus 1. Still have variables on both sides, so I'm going to see which way keeps it positive. I can see that if I subtract 5x from both sides, then I'm going to end up with a positive 3x over on the left. Now I'm going to subtract the 1, and 3x equals negative 15. Since 3 is multiplying with x, I'm going to divide, so x equals negative 5. Okay, this last example has parentheses in it, and remember, parentheses is telling me I have to distribute. And this one you got to be careful because I'm distributing a negative 7, so it's going to get trickier and trickier as we go. So 5, negative 7 times x is negative 7x, negative 7 times 1 is negative 7, and that equals 3 minus 10x. Here's my equal sign. I'm going to combine my terms. So I'm going to combine my negative 7 and my positive 5. And I get negative 7x minus 2 equals, I'm going to go ahead and rewrite this as negative 10x plus 3. Now I can add 10x and make it 3x. I can add 7x and that keeps it negative 3x. So I think I'm going to add the 10x to keep my x's positive. Again, it doesn't matter. If you don't care about, or negatives don't give you trouble, you don't need to worry about it. Now I'm going to add the 2. So 3x equals 5. Oh, I lost my negative. No? Oh, I did not. And now I'm going to divide by 3, so x equals 5/3. And it is okay to have fractions. Notice I did not make this 1.6 repeating. I left it 5/3. Your calculator will leave it in fraction form. And that's the way that we need to get into the habit of answering everything is in fraction form. Okay, so now we're going to start with the application problems or the word problems. And for this unit, all we're going to have you do is just write the equation. We've already practiced how to solve equations, so the hard part is to come up with what the equation is implying as you read it. So I've got a bunch of different types of examples, and hopefully these will help, and then we'll do more on practice on your assignment, reviews and things like that, and hopefully it'll get easier and easier. Okay, this first example, it says write an equation for x if the area of the rectangle is that means equals 133 square units. Well, area is length times width. So I multiply these two sides together, and so the equation is 7 times 3x minus 2 is or equals 133. And there's the equation. Okay, the next one, Sam weighs 170 pounds. Okay, so I know that number means something. He is loading a freight elevator with identical 69-pound boxes. The elevator can hold no more than 2,000 pounds. If Sam rides in the elevator with the boxes, how many boxes can be loaded? Okay, so we know we're starting with Sam's weight, and we're adding the boxes in with them, and we know the boxes' weight are 69 pounds each. We don't know how many boxes, and so we're going to set it equal to 2,000, and that's how many boxes will make it equal, and so we will answer. If it says, it's 15.8, well, it'll be 15, because if I do 16, it'll go over. But we're not solving, so we're just writing equations. Okay, Brooks sold his car for $8,700. This is talking about the amount of money, $8,700, is equals 100 more than 2/5 of what he paid for. How much did he pay? So X is going to be what he paid for. So I'm ready. 8,700 equals 100. Now the words more than or less than, put it in the second position on the equation. 2/5 of what he paid for. And there's the equation. Mrs. Bellish is a retiree. Will lose some retirement benefits if she earns over $8,000 per year working. If she has already earned $6,500, for how many more hours may she work at $7.50 per hour without losing her retirement benefits? Okay, so I know the big total is $8,000. She already has $6,500, and then she makes $750 an hour. And there's my equation. If Alice loses 16 pounds, 9 pounds, 11 pounds during the first 3 months of her diet, how much will she have to lose during the 4th month so she'll have an average weight loss of 12 pounds per month? Okay, average. Remember, average is add up and divide by how many, and they're asking for 4 months. Well, month 1 plus month 2 plus month 3 plus the unknown month 4 divided by the 4 months, we want that average to be 12. And there's our first start of linear equation solving and application problems.